a world dominated by water. Trillions of gallons flow freely across the surface of our blue-green planet. While we once thought oceans made our planet unique, we're now coming to realize that ocean worlds are all around us. Our planet retains its atmosphere and, in turn, its abundance of liquid water, thanks in part to a very strong magnetic field, which provides protection from the solar wind. Without this magnetic field, our atmosphere would be stripped away, leaving the pale blue dot looking more like one of our neighbors. Scientists believe Venus's early oceans evaporated. With no water left on the surface, carbon dioxide built up in the atmosphere, leading to a runaway greenhouse effect that created present conditions. Likewise, Mars appears to have had oceans long ago, but the red planet's global magnetic field decayed, leaving it vulnerable to atmospheric erosion by the solar wind. Farther from the Sun, in the sub-freezing temperatures of the outer solar system, it may seem impossible for liquid water to exist. However, not only does it exist, but in some places, it may be more abundant than on Earth. Jupiter is orbited by at least 3 moons that contain oceans: Europa, Ganymede, and Callisto. Europa is crisscrossed by cracks and semi-rectangular features that look like ice rafts frozen into the surface. Below those immobile icebergs, researchers believe there is a vast ocean just below the icy crust, warmed by the tidal forces of Jupiter, containing about twice as much water as is found on Earth. In 2014 and 2016, the Hubble Space Telescope has observed what appear to be water vapor plumes coming out of the cracks near the South Pole.
So Europa is one of the 4 major moons of Jupiter. It's about the same size as our own moon, but it looks very different. It's got a smooth, bright, white surface covered in these dark cracks and red patches. The reason for that, and what makes Europa so incredibly interesting, is that it's thought to be engulfed by a global ocean under a thick crust of ice. In fact, it's got twice as much ocean as planet Earth. If we have a salty ocean in contact with a rocky core and energy from a variety of sources, as we just heard from Mary, we have many of the ingredients thought to be necessary for life. In 2014, we used the Hubble and detected evidence of what are probably water vapor plumes emerging from the surface of Europa. That's important because it could be giving us access to subsurface liquid water without having to drill through miles of ice. In 2016, the new observations that we're just publishing, we saw a similar candidate, almost identical in appearance and at the identical location to one of the 2040 candidates. It's very important in an intermittent phenomenon to establish repeatability. It gives us a lot more faith in the observation. The other thing it allows us to do, given the position of Europa, given the position of the candidate on Europa, is to look with more fidelity at that position and see what else we can find there. If we just look at a map of Europa, we don't see anything particularly remarkable about the exact location of the plume candidate shown by the green ellipse. But if we look back to the Galileo data, Galileo in the 1990s published a thermal image, and right at the peak of the thermal image, that's where the plume candidate is. This hot spot on the surface of Europa, on the Europa night side, was identified at the time as a thermal anomaly, and it's sitting right on top of the position of our plume candidate.
Photos of Ganymede from the Galileo space probe show ancient ice flows frozen into its surface. Moreover, Hubble has looked at Ganymede's auroras and seen signs suggesting an ocean's worth of salt water. Hiding beneath a thick crust of ice, the ocean on Ganymede could actually harbor as much as 4 times more water than all of Earth's oceans combined. Callisto also seems to contain a saltwater ocean beneath the icy crust, betraying its presence by the effects of Callisto on Jupiter's overlying magnetic field. In 2005, NASA's Cassini spacecraft found Saturn's moon Enceladus busily puffing plumes of water vapor and organic compounds out through fissures now known as tiger stripes in its frozen carapace. Cassini flew through the plumes frequently since then and has discovered nanosilica grains and the presence of molecular hydrogen, both suggesting the movement of heated water on the seafloor of the icy moon. Other evidence provided by Cassini has convinced researchers that Enceladus has a global subsurface ocean spewing into space through these tiger stripes. Saturn's E-ring, the planet's second outermost ring, was actually formed from this water and ice. Saturn's largest moon, Titan, has a landscape dotted with lakes and seas. The liquid on Titan's surface is not, however, H2O. Researchers believe the fluid sculpting Titan's surface is a mixture mostly of methane with smaller amounts of ethane and other hard-to-freeze hydrocarbons.
Enceladus had turned out to not only be differentiated, but to have plumes, a warm global saltwater ocean, and hydrothermal activity. And if you notice that we just had a press release not too long ago that there is atomic hydrogen out in these plumes, all the ingredients for life on this little tiny moon. Absolutely earth-shaking discovery. Sorry, it's a bad pun. But really, just everybody was floored. We had no idea this was going to happen. And then on top of that, Titan was revealed to have lakes, a hydrologic cycle. Of course, it's not water, it's methane and ethane. Rain, clouds, rivers, estuaries, and it too has a subsurface ocean. So we've got two places that really just need to be kept as pristine as we possibly can.
Well, thanks, Jim. Well, Cassini has been in orbit around Saturn for almost 13 years, and our unexpected discoveries about Enceladus have been some of the most surprising. Today, we're publishing a paper about our recent findings by Cassini on Enceladus. We've detected hydrogen in the plume of Enceladus. That hydrogen is coming from a hydrothermal vent on the seafloor of Enceladus, going out into space through the plume. And so this is a very significant finding because the hydrogen could be a potential source of chemical energy for any microbes that might be in Enceladus's ocean. So this is a very exciting finding for the Cassini team. Now, Enceladus is too small to have retained the hydrogen when it formed. And so the hydrogen we see today, the hydrogen gas, is coming from inside Enceladus. So let's take a quick look at some of Cassini's past findings. With this first image, this is a view of the south pole of Enceladus, and the geysers or the jets are coming from those 4 cracks we nicknamed tiger stripes, those bluish fractures that you can see at the south pole of Enceladus. In the next picture, you can see that these jets are shooting out into space, forming the giant plume around Enceladus. Underneath that icy crust, as Jim said, there's a global ocean. That global ocean sits on top of a rocky core. And some of Cassini's findings pointed to hydrothermal vents, basically hot water coming out after it's been mixed with the rocky core. And this final image shows a thermal map, the temperature of the South Pole. And we can see the warmest temperatures with the yellow and red are right along the tiger stripe fractures.
Other bodies around the solar system also show signs of liquid water. In 2014, scientists using the European Space Agency-led Herschel Space Observatory detected water vapor coming from 2 regions of the dwarf planet Ceres. NASA's Dawn probe reached Ceres in 2015, and while the water vapor had subsided, there were other signs of water. Ahuna Mons is an ice mountain apparently formed from repeated eruptions of salty, muddy water. Also, widely reported bright spots in Ceres crater Akator are thought to be deposits of salt left behind by the escape and sublimation of briny water from below. Even distant Pluto may be an ocean world. As revealed by the recent flyby of New Horizons, Pluto's strangely molded surface features suggest the presence of a liquid underground. As astronomers look beyond our solar system, they are finding exoplanets of sizes and distances from their stars that could have oceans. And based on our solar system, these exoplanets could potentially have moons with oceans as well.
The Europa Clipper will orbit Jupiter, but it makes very close flybys of Europa. It has instruments like the magnetometer, once again, that will make measurements of its ocean. It also has an ice-penetrating radar. This radar will tell us how thick or thin these ice shelves are and how close then the ocean might be to cracks. The next major instrument that it has is thermal imaging. Going back to what we learned from Enceladus, how hot are these areas? Are there cracks there like we see now with the plumes from the Hubble observations and the hot spots still being hot from Galileo observations more than 15 or so years ago? In addition to that, we have a UV spectrometer. This imager is going to be the plume finder. So as we go back and orbit out away from Jupiter, we're going to look back at Enceladus. We're going to be looking for those plumes and then diving back in. And hopefully, if everything works right, flying through the plumes much like Cassini has done at Enceladus. But now we'll have the right set of observations to make. On that spacecraft, the Europa Clipper will have an advanced mass spectrometer. Actually, Hunter Waite is our principal scientist, our principal investigator for that instrument. So what a fantastic time coming up. These observations are really informing us of major things happening in these ocean worlds right now. What I really want you to walk away with is we're pushing the frontiers. We're finding new environments. We're looking in a way that we've never thought possible before for environments in our solar system which may harbor life today.
The locations of water within the diverse environments of our own planetary system will guide and inform the search for oceans beyond our solar system. Next time you look out over the ocean, think about our neighboring worlds. They may have more in common with our own ocean world than we once believed. To science.nasa.gov.